Hello everyone, welcome back to part 2 of speed time graph. Now imagine we have an object that is moving like this. He is moving in such a straight line, remember? In this kind of motion, this object is moving at constant acceleration. Okay? So at 0, the object was here. 10 seconds later, the object speed is 12 meters per second. Now, the important question here is, in these 10 seconds, what is the distance covered by this moving object? Think about it. This is a speed time graph. There is no distance here, but there is a way to calculate distance in a speed time graph. So, what do you think is the way to calculate distance here? We all know the formula for distance is speed times time. So you may be wondering, I know the speed is 12 and the object speed is 12 when time is 10. So maybe the distance is 12 times 10 and you get 120 meters. Is that correct? Well, it's wrong, but the idea is there. Okay, the idea is correct. We find distance by speed times time. Now, this distance, 12 times 10, this is only true if his motion is like this. If his motion is this straight line, then we can use 12 times 10. But in fact, the motion by this red line, the distance is actually half of 12 times 10. So, the correct way of calculating distance is half times 12 times 10, which is actually 60 meters. Now, half times 12 times 10 is actually the area of this triangle. So, what have we learned here? In a speed time graph, if I want to find distance, I have to calculate area. Area of what? Area of whatever graph I have. Okay, the area enclosed by this line and the x-axis, which is this red region. Now, if we apply the same idea here, okay, how do I find the distance covered by this moving object in the first 5 seconds? It is just the area between the line and the x-axis. So where is that? It is this region, which is the triangle. So the distance covered in the first 5 seconds of this object is the area of this triangle. So distance is, area of triangle is half times base times height. My base is 5. My height is 6. So 15 meters. Therefore, the object covers a distance of 15 meters in the first 5 seconds. Now, let's consider the following case. This is a speed time graph of another moving object. First question, what is the distance covered in the first 4 seconds? Apply what we have just learned. The distance covered in the first 4 seconds is this area. And this is a triangle, so distance is the area of this triangle, simply half times base times height. The base is 4, the height is 8, so it's 16 meters. So this region represents 16 meters. Next, what is the distance covered from 4 to 10 seconds? The same thing is the area of this region, the area bounded by the line and the x-axis. And this blue region is a rectangle. So how do you find area of a rectangle? Length times breadth. So length is from 4 to 10, which is 6. And the breadth is from 0 to 8, which is 8. And you get 48 meters. So this is a distance of 16 meters and this is a distance of 48 meters. So the total distance covered by this moving object in the first 10 seconds is simply 16 plus 48. So, a possible question that can be asked is, in this speed time graph for this moving object, what is the object's average speed? Recall the definition of average speed. What is average speed? Average speed is total distance over total time. So, when you have a speed time graph and you are asked to find average speed, you have to find total distance first, which is what we just did by finding the area of all these regions. Once you have total distance, you divide by total time. So what is the total time taken by this moving object? It is simply 10 seconds because the object only moved for 10 seconds. And thus, the average speed of this object is total distance of 16 and 48. Divide by total time, which is 10. And you will get 6.4 meter per second. And that is how you calculate average speed here. You have to find total distance first by calculating the areas, and then you divide by the time taken. So, to summarize, in a speed time graph, we know that the gradient represents acceleration. And if I want to find distance, the distance is simply the area between the lines and the x-axis. So it's the area of this red region. Now, it's impossible to find straight away the area of this. So what do we do? Okay, as what we saw just now, we break up this region into shapes that you all recognize. For example, I can break up this region into a triangle, a trapezium, and another trapezium. But if you forgot how to find the area of a trapezium, then I can break the trapezium into a triangle and a rectangle. For this trapezium, I can break it up into a triangle and a rectangle. So, distance is area under, okay, is the area under a speed time graph. And if the area is something that you can compute at once, break it up into shapes that you recognize. And lastly, if you want to find average speed, and as you know, average speed is total distance over total time. You have to find the total distance first by finding the area and divide by the total time, which is this value here, and you get average speed. And that is all for this section.